So this is 4.6b, College Algebra, Applications and Models, Growth and Decay and Compound Interest, page number 411. We did population growth. Now we're going to look at interest compounded continuously. And what we're going to do is we're going to look at a formula which is exactly like the one we just worked on. So P of t equals our original principal, E and KT. Now notice I said principal instead of population because we're doing interest, and principal is the amount of money that we invested. Okay, and in this case K is going to represent the interest rate compounded continuously, and P of t is again the amount of money in the account after a certain number of years, or after t years. So if we look at example 2 on page 412, it says that we invested $2,000. Okay, so that $2,000 ends up being our original amount. So that's $2,000 at an interest rate of K. So our interest rate is K, compounded continuously, and grows to $2,983.65 in 5 years. So first thing they want to know is, what is that interest rate? What is K? That's what we're looking for. So first of all, we just need to start writing down, plugging numbers into this formula that we have here in order to find everything except K, so we can go ahead and find that. So let's go ahead and do that. At time is 0. At the time we invested money, we put in $2,000. And other than that, we know that in 5 years we're going to have $2,983.65. because he told us that in the equation. So let's go ahead and write what they've given us. So we're going to replace our final amount as $2,983.65, and that's going to equal our original amount, 2,000. So we started out with 2,000. By the time we pulled it out, we had 2983. So we'd gotten quite a bit. E, K, and again 5 years is our time there. So I'm just going to replace this K times 5 and just put it on there as 5K. There, just like that. Okay, then I can just do my algebra, and I'm going to divide both sides by 2,000. Trying to get as much on the right hand side alone as I can. Okay, now again, my that disappears. So again, what I've got is exponents, and my variable K is one of my exponents here. So that's what I'm trying to solve. So because of that, I can do the logarithm on both sides. But since I'm dealing with an E, I'm going to take the natural logarithm. So I'm going to take the natural logarithm of this side and the natural logarithm of that side. So when I take the natural logarithm of that, this goes away and it just becomes 5K. So I can take all of this and replace everything, except I can't cross this out, so we'll just put 5K. So I'm going to divide both sides by 5, divide that by 5, that goes away, and I have my K. So what I'm going to do is I'm going to take this here and divide it out, take the natural logarithm of it, take that answer and divide it by 5, and I get 0.08, and that's the number that's close to K. So the interest rate at 0.08 that we are looking for is approximately 8%. Okay, So section B says find the exponential growth function. So what I'm doing now is I am going to get rid of all of this stuff here, and I am going to replace the stuff in this original problem here with the information I know. Like I just found out K is 0.08 or 8%. I know this is 2,000, and so then I've got my problem written. So let's go ahead and write this as P of T. We write P of T. We don't write the 2983 anymore because that was only on one particular problem. So the amount of money we make over a certain period of time is going to be what we started with, e to the 0.08 t. Okay, so that means that we have a general formula right here, so that no matter how much time we put in here, when we do this work, we're going to get a number here based on $2,000. We put $2,000 in there, and you want to know, okay, in 6 months, how much money am I going to have? Put a 0.5 up here, and it'll tell us how much money we're going to have at the end of 6 months. If we put 30 years up here, it'll tell us how much that $2,000 will worth. So this general form of the equation only works when we put $2,000 in. Okay? And when we put $2,000 in, that's what it's going to kick out, is how much money we're going to end up making. So C says, what will the balance be after 10 years? Well, all I have to do is put a 10 here. And then I'll take 10 times 0.08 and get 0.8. And I'll take e to the 0.8, take that answer, multiply it by 2,000, and I've got an answer there. So I'm not even going to do C. D says, after how long will the 2,000 have doubled? Okay, so that's the doubling time that we talked about before. So not too terribly difficult. We put $4,000 in here because that's how much money we're going to hopefully have at the end of the time period when it's double. So we already know the answer. We're putting $2,000 here, which we originally started with. We've got our E, we've got our 0.08, and we have our T. So what we're looking for is that right there. How many years is it going to take for our $2,000 to double to $4,000? So again, we divide both sides by 2,000, and if you remember from the last one when we did a doubling, our answer is always a 2 right there. So we get 2 equals e to the 0.08 t, and then we take the ln of both sides. Ln of 2 equals ln e of 0.08 t, and if you remember, when you have ln of e, this goes away, so we just have ln of 2 equals 0.08 t. Divide both sides by 0.08 to get rid of that, and that goes away. So we have ln of 2 divided by 0.08, and it's 8.7 years. So when we put that $2,000 in, we let it sit for 8.7 years, we'll have $4,000 when all is said and done. Which, this formula that we came up with, ln of 2 divided by 0.08 equals t, for doubling, that gives us an equation, in fact 3 equations when it comes with doubling time. Okay, so right here we have ln of 2 over 0.08. 0.08 is a capital T, that would be the time, or the doubling time. So ln of 2 over the doubling time is going to equal k. Or, so if we have ln 2 over the doubling time, that's going to be our k. And that can be written all different ways. It could be written as kt, cross multiply, equals ln of 2. And it could also be t equals ln 2 over k. So those 3 different possible equations are on page 414 in the purple box.